Right here is the, I believe, fourth video of the How to Do Integration by Parts series. This one we're going to solve something for the first time with a clear g and f of x that we don't have to make in the problem. If you haven't checked out the videos prior to this, you really should. It'll enhance your learning. Anyways, we're going to continue on with this video. If we need to solve the integral of x times sine of x dx, we need to think of one thing that is the derivative of something and something that has an EC derivative. So as a general rule, when you have an x to some power, you're always going to want to take the derivative of that. So in the worst case scenario, you'll at least have some answer no matter how many integrals inside the integrals you have to solve for. For example, after you do the integration by parts inside that integral, you will, in the x value, at least have an integral of a lower x power. So in this case, we are going to, even though x is just 1, we definitely don't want to raise the power. Sorry, it's so hard for you guys to see, so we're going to say x is g of x, that way we take its derivative. That means that sine of x has to be sine of x has to be f of x. So this is going to be equal to this is sine prime of x. So something's derivative equals sine of x. Well, cosine's derivative is negative sine of x, so negative cosine of x's derivative is sine of x times x minus the integral of x prime, which is 1 times minus cosine of x dx. So now we are going to evaluate this as negative x cosine x. We have two negatives here. It's just going to be plus the integral of cosine x dx. And so this is negative cosine of x. Something's derivative equals cosine of x, well that's sine of x. So it's plus sine of x. That right there is your answer. Thank you much for watching, or plus c at the end. What am I even saying? That right there is your answer. Sorry about all the blurriness in the video. I hope my explanation was clear and I've helped you out in understanding integration by parts. Thank you much for watching, and goodbye.